Hello, my name is Bob McKinnon, and today we're going to look at the Proximate Determinants framework and how it relates to Spectrum's FamPlan module. Okay, let's get started. I'm going to open up Spectrum, and I'm going to create a FamPlan projection. I have selected New up here, which brings up the projection manager. I'm going to give it a file name. I'm going to call this Proximate Determinants Test. We'll save that. I'll keep the default years. I will turn on the FamPlan module, and I'm going to select the Country Data tab. And let's select Malawi. And if you look over here to the right, it's showing you which default data is going to be used. So we're asking it to load in default data for DemProj, or the demographic data. But also it's going to load in default data for family planning. And if you look to the right here, it's indicating that it's going to load in the DHS survey for the year 2004. Okay, we'll select OK. Hit OK again, and Spectrum has made our projection. Now that our projection has been loaded, we can move over to FamPlan's data editors, where we can take a look at a policy analysis screen that will demonstrate the Proximate Determinants framework visually. We do that by selecting Modules, then the FamPlan icon, and then finally the Policy Analysis button. And what that does is brings up this Policy Analysis screen with the Proximate Determinants data preloaded. So this screen models the Proximate Determinants framework that John Bongartz developed back in the 70s. And basically what that is an equation which relates the fertility factors over here to the total fecundity. The total fecundity in this case is the number of children a woman would have in her lifetime if all of the inhibitors to fertility were removed. So what we do is we go back to a previous year where we have historical data or known data. In this case it was 2004 when the DHS survey was taking place. And we plug in the numbers into the equation and solve for the total fecundity. And in this case it came out to just slightly over 20. Now we can go to a future year and we assume that total fecundity remains constant, and we're able to then change the various fertility factors and then resolve for the TFR. Before we make any changes to the data, let's see how the data down here relates to the chart above. Remember that our total fecundity was calculated just over 20, and you will notice that both of these bar charts end in 20. And each section here corresponds to a particular fertility factor. Now, depending upon the size of the section, that shows you how much can be attributed in the reduction of fertility to that particular factor. So in this case, it looks like the largest is in union, and the smallest is probably the abortion rate, which is here. Now, let's move down to make a change and see how it affects the final year bar. So we'll look at in union right now. So we'll reduce that. And what happens? Well, the first thing we can notice is that the size of the in union section has greatly increased compared to the base year, and the total fertility has actually decreased to about 3.5, and you can look down here and you'll actually see that it was 3.48. So if we increase in union again, you'll notice that the TFR does increase as expected, and in union shrinks, or the size of the in union section does decrease. So now let's look at contraceptive prevalence. So we would naturally assume if we increase prevalence or more people using, then that should have a reduction in fertility or in the total fertility rate. So let's see if that happens. So as I increase it, yes, the TFR does move down. Then we can move down to sterility, and if we increase that, you will also notice now that sterility has a greater impact in the chart, in this particular bar chart, and TFR did move down slightly. And total abortion will do the same. We'll increase that. And TFR again moved down, and the size of the total abortion rate section did increase. And if we look at postpartum, and let's see, we'll increase postpartum, and again we have further reduction in fertility. And we can notice that the postpartum section also increased. The general idea here is as a particular fertility factor section increases, it pushes down the TFR at the bottom end. And then the reverse is true. As a particular fertility factor decreases in size, the TFR will then expand to fill the gap. And this all works because we do hold the total fecundity constant. Now, one factor that does contribute to the framework here is the overall effectiveness of the method mix. And although you can't change that here, you can view the method mix. And we do show it for the survey year and the final year. And in this case, you'll notice that they're both the same because we have not changed the method mix. And this data is pulled directly from the FAMPlan editors, like the data in the previous tab, or the effects tab. Let's move back to the effects. And I'd like to point out that we do have a help button down here, which does have some information on the various fertility factors. Now let's look to see where we can find this data in the FAMPlan data editors. And I'd also want to point out that this is a one-way transfer. So if we do change any data here, it's not saved, it is not pushed back into FAMPlan, but any changes we do make in the FAMPlan editors will be reflected here the next time you visit. So let's close. And let's move over to the FAMPlan editors. So I'm going to select the Family Planning tab here. And you notice the first tab here is the method mix. And our survey year was 2004, which was here. And the final year was 2016. So if we did make a change here to the method mix, it would be reflected back in the policy analysis window. And the proximate determinants can be found here. Again, we'll have the 2004 and 2016. And then the final tab to point out would be the effectiveness for the various methods that are in your mix. Okay, well that concludes the video. Thank you.